Welcome to the session on training and deployment of custom AI models. We'll explore how to leverage SAP Business Technology Platform to deploy your custom model using AI Core and AI Launchpad services. Our session will follow these four aspects. First, we'll provide an overview of what custom AI deployment on BTP is and the key benefits of using BTP for this purpose. Second, we'll cover the essential prerequisites you need to have in place, both commercial and technical, to leverage BTP for custom AI deployment. Third, we'll explore the key choices that you should make to effectively use BTP services to support deployment and to scale your AI applications. Fourth, we'll dive into the step-by-step process of using BTP services to deploy your custom model. As every organization strives to improve the speed and cost effectiveness of its operations, AI is playing a significant role in achieving these goals. Depending on your specific business needs, you might need to build a tailored AI solution that requires a custom AI model. Using your custom predictive models within SAP BTP helps you scale your AI application and integrate it seamlessly into existing business processes. Before deciding to build a custom AI model, it's recommended that you first review the SAP Business AI strategy and its portfolio of out-of-the-box offerings to find a solution that suits your business needs. If you haven't found a suitable solution, then it's time to consider the deployment of custom predictive models on the SAP BTP platform. The primary goal of this practice is to effectively integrate custom AI models into an existing business structure, maximizing the utility and impact of AI technologies. It aims to optimize operations and provide decision-making and deliver scalable, sustainable AI improvements that align well with your business goals. Building custom models and using SAP BTP services such as AI Core and AI Launchpad provides multiple benefits. The first benefit is improved operational efficiency and data-driven decision-making. Predictive models can automate routine processes, reduce manual effort, and deliver real-time insights. This supports better decisions across business areas such as logistics, procurement, and finance. The second benefit is AI at scale with seamless integration. SAP BTP makes it possible to connect AI models with both SAP and non-SAP applications. It can draw on data from SAP HANA, CDS Views, SAP DataSphere, and OData services, ensuring that insights are delivered directly within business workflows. The third benefit is personalization at scale. AI models can enable hyper-personalized experiences in sales, marketing, and customer service by anticipating customers' needs and preferences. Finally, custom AI deployment on SAP BTP helps developers scale their applications and integrate AI features seamlessly into business processes. To better understand this topic, let's review a few important concepts. Narrow AI, also known as the main specific AI, is a subset of artificial intelligence designed to solve specific business problems. For example, it can be used for demand forecasting or predicting payment defaults, usually by analyzing historic data. It can model lifecycle management, refers to the step-by-step process of building and managing AI models. This includes data acquisition, pre-processing, feature engineering, model training, validation, deployment, and ongoing monitoring. Explainability and trust are essential as businesses rely on AI for decision-making. Responsible model development should provide interoperable insights. Testing techniques such as SHAP or LIME to ensure stakeholders can understand and trust the predictions. Finally, there is a difference between real-time and batch inference. Real-time inference provides immediate predictions based upon input, while batch inference processes a group of inputs together at once. Let's look at some examples of how custom AI models can be applied in businesses. Payment default prediction helps identify customers or invoices that are at risk of late payment, allowing finance teams to take action before delay occurs. Sales forecasting and deal conversion use historical opportunity data to predict which deals are likely to close and when, leading to more accurate sales planning. Custom demand forecasting by region or channel enables granular forecasts tailored to specific products, locations, or sales channels. Supply or lead time risk prediction identifies purchase orders that may face delays by analyzing historic delivery patterns, supplier behavior, and external signals. Productive maintenance for custom assets can forecast failures in industry-specific or non-standard machines by monitoring operating parameters. Employee exit risk modeling helps organizations understand workforce dynamics by detecting attribution risk based upon custom internal metrics rather than generic benchmarks. Custom product return prediction estimates the likelihood of returns based upon factors such as order combinations, customer type, and past behavior. Turn risk for subscription-based services uses data such as usage patterns, ticket volume, and satisfaction scores to forecast potential customer churn. And finally, warehouse inventory risk modeling highlights items that risk of going out of stock by analyzing historic movement data, product life cycles, and seasonal trends. Before implementation, let's cover the prerequisites you'll need on SAP Business Technology Platform. First, you'll need an SAP BTP sub-account with subscriptions to SAP AI Core and SAP AI Launchpad. If you plan to store data or use HANA-based machine learning algorithms, you'll also need an instance of SAP HANA Cloud. Pricing information for these services is available in the linked resources. Now let's provide a bit more context around these prerequisites. SAP Business Technology Platform is an integrated suite of cloud services, databases, AI capabilities, and development tools. It enables businesses to build, extend, and integrate both SAP and non-SAP applications efficiently. SAP AI Core is a managed AI runtime. It provides scalable execution of AI models and pipelines with seamless integration into SAP applications and data on BTP. It supports the full lifecycle management of AI scenarios. SAP AI Launchpad is a multi-tenant SAS application. It helps organizations manage their AI use cases and lifecycles around multiple AI runtimes. SAP HANA Cloud is a database as a service that supports in-memory query processing. It provides a one-stop solution with in-data-based capabilities for relational graph, spatial, vector, and semi-structured data, along with embedded machine learning algorithms. By setting up these prerequisites, you'll establish a strong foundation for implementing and deploying custom predictive models efficiently and at scale. Let's take a look at the high-level architecture for building or deploying a custom AI model on SAP BTP. For all custom workloads, SAP AI Core and SAP AI Launchpad form the central components. They provide containerized deployment and make it easy to manage workloads through the Launchpad interface. Within the deployed container, you can connect to a variety of data sources, whether SAP line of business solutions, SAP data storage solutions, or external data sources. This enables you to train your models and expose an interface endpoint. The endpoint offers a simple API interface for further integration. To simplify back in complexity, SAP Cloud Application abstracts technical details. It also manages authentication and authorization by leveraging SAP Identity Services. Finally, your front-end application can connect to this back-end component and seamlessly consume the AI features directly within the business application. Let's discuss some key decisions that impact the overall development and deployment of your AI models. First, problem definition and business alignment. Clearly defining the machine learning problem and aligning it with your business goals is critical to drive measurable value. Engaging stakeholders early ensures that you capture domain specific insights and other factors that may influence your model. Second, your data strategy. Data quality is crucial. Focus on collecting high quality representative data while ensuring ethical sourcing and, compliance with regulations. Pre-processing and feature engineering maximizes model effectiveness and fairness. Because many AI use cases require large amounts of data, processing data close to the source reduces movement and latency. If your data already resides in SAP HANA, it is recommended to leverage HANA-based pre-processing and built-in machine learning algorithms. Third, model development. The choice of algorithm should be guided by problem complexity, interoperability, and data availability. A good approach is to start with simpler algorithms or smaller models and increase complexity as needed to support your business case. For deep learning scenarios, consider using pre-trained models to accelerate development. Finally, model evaluation and validation. Since machine learning models automatically detect and interpret underlying patterns, it's essential to validate them thoroughly. Use robust metrics, cross-validation, and edge case testing. This ensures your models are reliable, resilient, and ready for real business applications. Choosing the right resource plan is an important step in training and deploying custom models. Training and inference require compute resources, and SAP BTP offers a variety of resource plans tailored to different use cases. Selecting the right plan helps speed up training cycles, reducing inference latency, and they remain cost effective. For example, small training resource plans are suitable for classic regressors, decision trees, gradient boosted models, and simple neural networks. Small inference resource plans can also be used to serve those models in production. Meanwhile, large influence resource plans are designed for more demanding workloads, such as large language models, computer vision models, and deep neural networks. Now let's move to deployment and ML operations. It is a best practice to use MLOps tools to ensure reproducibility, deployment, scalability, and automated monitoring. Always set up MLOps or CI/CD pipelines for secure and efficient model releases. SAP AI Core supports this by using containerized Docker-based deployments, making it easier to scale AI applications. Let's now highlight some critical considerations for running AI in production. First, monitoring and retraining. It is essential to continuously track model performance after deployment. Monitor for data drift, capture user feedback, and establish retraining workflows to maintain accuracy and business relevancy over time. Second, security and privacy. In enterprise applications, safeguarding data and models is paramount. This includes encryption, strict access controls, and defense against adversarial attacks. Privacy should also be ensured through techniques such as anonymization, federated learning, or confidential computing, where applicable. Finally, AI ethics and responsible AI, embedding fairness, transparency, and accountability across the entire model lifecycle is strongly recommended. Explainability tools, as well as documentation methods like model cards, help support ethical governance and build trust with stakeholders. Deploying a custom model on BTP is a step-by-step process that can be done using the SAP AI Launchpad or using the command line interface in Visual Studio Code. Let's start with the AI Launchpad, which provides intent and mail model lifecycle management. To deploy your custom AI model in AI Core, you need to perform these steps. The provided links will take you through this journey step by step. The first step is to set up your landscape, including your AI Core instance, an AI Launchpad subscription, and connect AI Core to your AI Launchpad. Then connect your Git and container repositories to AI Launchpad, and you are ready to start the deployment. If your model is not yet ready, you can leverage SAP best practice content to build your narrow AI models. These best practices cover a variety of ML scenarios and provide guidance on achieving best outcomes. A reference example will help guide you through the development and deployment of the models. If your ML model deployment where inference requires GPUs, SAP AI Core provides instances which have GPU support to accelerate your model deployment and inference speed. When you're running your workload on AI Core, you can generate several metrics, which can be compared with an AI Launchpad to check the performance improvements in model deployment cycles. Once you are satisfied with your results, an inference pipeline deployment will help you make predictions for your AI model. With the above process remaining the same, there's another way that some programmers might prefer to use. SAP AI Core Toolkit for Visual Studio Code provides all functionalities with a command line interface, and associated learning journey guides you through the step-by-step process to set up and use this toolkit. The best practice guide reflects the collective expertise of SAP AI specialists from across SAP, binding together insights to support your journey. Thank you for watching this session on training and deployment of custom AI models. We hope the information provided helps your successful implementation, AI capabilities in your business applications.